Hello students, today we are going to continue kinematics, in which we will do the curvilinear motion, and after that we will proceed to kinetics. So my name is Ankur Agrawal. I am teaching engineering mechanics and this is my 10th lecture. So let's proceed. So we have seen, so far we have seen rectilinear motion, in which we will take the direction of motion of a body only in 1D. Whereas in curvilinear motion, we will take the motion of the body in 2D or 3D. Right? So, motion of a body which is a combination of 2 or 3 rectilinear motion. That means the body is doing motion in 2D or 3D. That motion can be count as the motion in 2 rectilinear motion, the motion in 3 rectilinear motion. Suppose, let's take some example. Suppose a body is been having this kind of motion in a space. Let's consider this is a 3-dimensional motion, right? So what was the body had done? Body had displaced from this point A to this point B, right? So how we will do this thing now? We will take the position vector from this, and we will take the position vector from this point. Simple. And we will break down all the equations, which we have seen for the uniform constant acceleration, constant acceleration, and the equation for non-uniform acceleration. Okay, so we will break down all this equation in the x coordinate, in y coordinate, and as well as in z coordinates if required. Okay, so let's proceed. So here the position vector, it's r vector, is simple OB vector minus OA vector. So this is my initial position and this is my final position, right? So my this is not the position vector. Here this is the displacement vector. This is the displacement vector. Position vectors are r1, that is OA, and r2, that is OB, right? This is my displacement vector. So what I'll do, I'll just convert this in x, y, and z. That means I suppose this coordinate of this one is x1, y1, and z1, and the coordinate of this b is y2, z2, right? So what should be the displacement here? x2 minus x1, it's in x direction, plus y2 minus y1, this is in y direction, so j cap, plus z2 minus z1, this is in z direction. So for the z direction we place I cap, for y direction we place j cap, and for z direction we place k cap. Okay, so like this we will take each and every motion, curvilinear motion, in one rectilinear motion. Right? For sake, what I'll do is I'll take sx, I will take x2 minus x1. I will just part the, because this is the motion in x direction, right? Same the motion in y direction. I'll just break down just like this, same as sy equals to y2 minus whatever, right? Clear? Same I'll do with the velocity. Suppose the velocity of a point is here, like this. This is ua, and here the velocity, suppose in this direction, this is v. I will bring the velocity here. will take ux, that means ux. Okay, suppose take the u a b ux I cap plus, sorry, uy j cap plus uz k cap. So my ux, that means velocity in x direction. What is this? Ux. Okay, clear? Same velocity in y direction initial is uy. Velocity, final velocity in x direction. Let's change the naming here for this velocity v. This vb, v1, v1 in x direction, v2 in j direction, sorry, y direction, and v3 in z direction. Right? Same. So vx will be v1 and vy will be v2. The final velocity in y direction will be v2. Okay, so like this we will take all the parameters: displacement, initial velocity, final velocity, acceleration, forces, like this all. If we will not take the force here because we are doing currently kinematics, so we will consider only the these four parameters: displacement, initial velocity, final velocity, and acceleration. Okay, so let's take one example of this curvilinear motion, that is a projectile motion. Here we can see there is a man which has thrown some object in this direction u, and the projectile and the trajectory of this object after the man thrown in direction u is something like the thing which shown by the green color. Okay, so let's understand what things going to happen in this projectile motion. Let's consider our coordinate system. Firstly we will take our coordinate. This is my y direction. Sorry, this is my x direction and this is my y direction. Okay, so this is my x direction, this is my y direction. Okay, I have done the I have defined the coordinate. Okay, so see the topmost point. Just we have done the one numerical in which object is thrown vertically upward, and the point, topmost point, the particle having the object having the velocity 0 at that topmost point. Why? Because just before the that point, particle is moving vertically upward, and just after that point, particle was going downward. So at some point, because velocity direction is changing, so at some point velocity is to be 0. That is the topmost point. Same thing is happening here. Same thing is happening here with this object which is thrown by this man. That the topmost, see the topmost point is that the velocity in y direction is moving upward, and after this topmost point the velocity the particle is moving downward, like this. Here the particle is going here after this. So in y direction particle is moving upward till this point, suppose the point t, topmost point t, and after this point t the particle is moving downward. That means the motion of a particle or of the object is moving is downward. So at this point there will be no velocity in y direction. There will be no velocity in y direction. That means the velocity in y direction at the point t is 0. At the point t is 0. So what's the velocity here? The velocity will be only in x direction. Okay, so velocity here will be only in x direction. Right? Clear? This thing I think clear. I'm just explaining the projectile motion, how it's going. Okay, so velocity here will be ux, sorry, vx at point t. Okay, there will be no velocity in y direction. Let's consider one more point in which we'll see what things are happening at this point. At this point, okay, so the velocity, direction of velocity at this point will be towards the trajectory like this, right? Let's call this v velocity, Clear? Okay. Here, velocity can be further divided into one in y direction. Sorry, one in y direction, another in x direction. Same we can do with the velocity at which is thrown upward. Like this is my velocity in x direction, and this is my velocity in y direction. Okay, just let's name the velocities. This is my ux, and this is my uy, because this is the initial velocity, so I'm taking it u. Here the velocity will be vx. Let's take the point p here. So velocity here will be vx at point p, and here the velocity vy at point p. Okay, we have just seen the 3 points here: initial point, p point, topmost point, and some point p in middle. Okay, so we have seen the direction of velocity by which we can divide this velocity in 2 dimensions. Okay, clear? So one more thing here in projectile motion. In projectile motion, the motion in x direction, there is no force, there is no acceleration, right? The man has thrown the particle, okay, in this direction. That means after thrown, there will be no contact with the having the particle with the man. So after thrown, there is no contact, so there will be no force in x direction, but there is a force in y direction, that is the gravitational force, because of which it's experiencing some acceleration due to gravity. Okay, so there will be change in velocity in y direction, as we can see, but there will be no change in velocity in y direction. Sorry, in x direction. Why? Because there is no acceleration. So no acceleration, it means velocity in x direction will not be changed. Okay, so each and every point, at initial point velocity is ux. So ux should be equals to the velocity at t point. That means vx at t, and this also be equal to the velocity at point p in x direction. That means vx at point p. This all to be equal, because velocity in x direction to be equal, constant time. It will not change throughout the time of flight. जब वो particle उड़ रहा होगा मैं, तब उसकी velocity in x direction will not change because there is no acceleration. Okay, ये आपको पता होना चाहिए. Okay, now just what we will do, we will just find out the values of initial velocities in x and y. Suppose this particle is being thrown with an angle from the horizontal, that is theta. Right, now we can calculate the velocity in initial velocity in x direction as well as in y direction. Okay, so I will divide the motion in x direction and here in y direction. So ux, that means initial velocity in y direction is u. The component here is cos, so u cos theta. Whereas in y, uy equals to u sin theta. Clear? Ux is u cos theta. That means this is all equals to u cos theta. And suppose at this point, this particle having angle alpha with horizontal, so this vx, that means vx at p, it should be equals to this one. This should be equals to v at p cos alpha, right? Cos alpha. So horizontal velocity at any point equals to the initial velocity in x direction. Clear? This we can equate. This was one question I found that they are asking this angle at any point. The angle So they are asking because they have this velocity, so asking this for the angle, so we can easily calculate here for the angle. Okay, so this told you because of one question. Okay, yeah. Now what our purpose, we have to calculate for the questions. Okay, so we have to divide this projectile motion into. It will be very easy to solve now. Okay, ux, what will be sx? Sx will be, if we know the time of travel of this particle, we can find the sx. That means that will be ux into time, right? And this sx, as you know, that this sx will give the range. Range will be from same level. Okay, from the same, agar particle is thrown from this level, so this level, so the range is also from this level. Let's take the this same level. Okay, from here to here, the particle is the same level having the same range. दोबारा रिपीट कर देता हूँ. रेंज क्या होगी? रेंज होगी जहां जिस ग्राउंड से पार्टिकल फेंका गया है उसी लेवल पे, उसी सेम लेवल पे अगर हम ये आप निकालोगे, डिस्प्लेसमेंट निकालोगे उसी सेम लेवल पे, दैट सेम लेवल फ्रॉम द टिल द सेम लेवल, द डिस्टेंस इन एक्स डायरेक्शन जो होती है उसको बोलते हैं रेंज. ओके, द रेंज इज, it's the maximum displacement covered by the particle in x direction, in horizontal direction, when we consider the same level from which it's been thrown. Clear? तो ये range होती है. Okay, once I know the time, I can calculate the range. Okay, now here displacement क्या होगा यहाँ पे? Y direction में maximum displacement. If I take the same ground, it will be the maximum height. Maximum height. I will take its h, capital H. Maximum height होगी यहाँ से लेके यहाँ तक की maximum height होगी. I will take it capital H. Okay, clear? ये कैसे निकलता है? We know that initial velocity in y direction, and at this topmost point where we have taking the maximum height, वहां पर आपका velocity in y direction is 0. Okay. With this information we can also calculate the time, because we know यहाँ पर क्या लग रहा है, acceleration लग रहा है downward, right? Acceleration लग रहा है downward, और कितना लग रहा है acceleration? It is minus 10 meter per second or 9.8 meter per second. Okay, this we know. That means acceleration I know, ay is minus 9.81 meter per second or 10. Okay, whichever is given. If not given, we will consider this 9.8. Okay, this we can, this we know. How we can calculate time? We can calculate time if we take the half of this travel. Okay, if we take the half of the travel, initial velocity we know, u sin theta, and final velocity is 0. Okay, we just can apply the first equation of motion, vy equals to uy plus ay t. This time is half. Okay, so v is 0, u minus u sin theta upon, let's take this value as g. Okay, minus g, because it's acting downward, so I'll take this minus g. So this is u sin theta by g. Okay, this is the half time from initial to this point t, to this point t to some point here which is at the same level. Okay, let's take this point at the same level, this point at the same level, this point at the same level, at same level, right? At same level. यहाँ तक का टाइम जो होगा ट्वाइस कर सकता हूँ मैं. I'll do the twice. Okay, so time of flight will be 2u sin theta by t. This is the time of flight, right? This is the time of flight. Similarly, if you know time of flight, you can calculate the range. That is sx क्या होगा? Simply u cos theta into time. Time is, we have calculated u sine theta by g. U 2 sine theta cos theta by g, it will become 2 sine u sine 2 theta upon g. This will be our range. I repeat, range is the horizontal displacement covered by the particle in the projectile motion under same level. Okay, clear? We have calculated two things here, because see, I am doing this calculation just to show you how we have to done things. We have bifurcates the motion in x direction, in y direction. Okay, and I have done this in one question I have taken. I will not do this there. ठीक है, आप उसको यहाँ से रेफरेंस मार के यहाँ देख सकते हैं. Okay, so next part is calculate this the maximum height. So for maximum height we will use the terms which is in y. So let's copy the terms in y what we are having along with this figure. Sorry. Yeah. Now, once again. Yeah. Okay. Just see. So we have to find the displacement in y. So what we can do, we can just simply apply the third equation. Vy square equals to uy square plus 2as. Okay, we will apply this equation for the first half, that means initial position to the t point. Okay, so velocity, final velocity will be 0 at t. Initial velocity we know it's u square sine square, okay, plus 2 g is a is minus g and s y at this t point, that means the capital H, that means maximum height. Okay, our purpose is to calculate this maximum height. Just calculate, it will come out to be right. It will very easy to calculate this with the help of bifurcation by dividing the curvilinear motion in the rectilinear motions. Okay, so let's proceed with some numericals. Yes, so let's read the question. This is our fifth question of kinematics. So a projectile is fired horizontally at 6 meter per second from a point of height h. Okay, from here the particle is being fired. Okay, now above and falls 12 meter away from an object. Okay, and it will fall. कहाँ गिरता है? It will fall an object which is 12 meter away from it. जहाँ से फिर गया. Okay, so what is the value h required so that the projectile hit the object? Okay, so what do you want? They want to calculate the height from which if it's thrown from here with the velocity 6. अगर यहाँ से 6 velocity ये आपको फेंका गया है, then at what height it should be thrown? ठीक है? If it is to be hit the target, then from which velocity is being thrown? So here only horizontally, say the word is say horizontally, so here only ux is given. That means the velocity u equals to ux. That means this equals to the total velocity that is only having a direction in x. Right? Clear? So what we will do? We will take the direction in x. Initially, we will take the direction in x, and we will just try to calculate a time. How much time it will take, because we know the velocity in x direction. Okay, we know the velocity in x direction, and we know how much distance is to be covered, and there is no acceleration. That means easily what we can do. That means 12 meter. That means the distance in x direction, displacement in x direction is 12 meter. It should be equals to ux into time of flight. So here we can calculate a time of flight. That means 12 upon ux is 6. it come out to be easily 2 seconds. Time of flight we have calculated, it is 2 seconds. Now we'll take the motion in y direction and calculate the height. Okay, just see the motion in y direction. It's very simple to calculate by bifurcation. We know the acceleration in y direction is minus 10 meter per second square, right? We know that displacement in y is minus h because it's acting negative y, it's going negative y, so displacement is minus h, and we know the time, 2 seconds. Okay, as well as we know the initial velocity, initial velocity in y direction is 0, right? We can apply here second equation of motion, that is Sy equals to uyt plus half ayt square by h. We can, this will be my minus h, this u 0, so it will become whole 0, plus half minus 10, right? Ay is minus 10 into t. T we have calculated is 2, so its square becomes 4. This will become 2. It's come out to be minus 20 meter. Minus 20 meter, it's minus h, it will become h equals to 20 meter, right? See how easily we have calculated this. Okay, clear? So let's move to next question. So this is my next question this is for today's lecture, and 6th question for our kinematics part. Okay, so let's read the question. The stone is thrown with the velocity 10 meter per second by making an angle 60 degree with horizontal. What will be the maximum height, range, and time of flight? Okay, for this question I have wasted the initial time. Okay, for this question only. Suppose this is the object is being fired in this direction and it's traveled like this. It's called the projectile. Now I will not calculate all the things which I have calculated before. Suppose this is the velocity u at which it is thrown. This is u, and u is given 10 meter per second. We have given a direction from horizontal. It is theta equals to 60 degree with the horizontal. Okay, so we have to calculate the range. This is our range. We have to calculate the maximum height, right? And we have to calculate the time of flight. It's all we have seen just before. Here, this is the range, this is the time, right? And this is the maximum height. Okay, just put the values u, put the values of u, g, and theta. You will get the answer from here. Okay, so these are the answer for your reference. And one more thing, in the calculation of range, this u and this u will combine to get the u square. We got left in this there, so let's correct. Okay, so for your reference I have write the formulas here, and these are the answer. You just check. So now let's move to our next question. So this is our next question. So let's read what question says. A particle is projected at an angle 37 degree with the inclined plane in upward direction with the velocity 10 meter per second. The angle of inclined plane from which it is thrown is 53 degree. Then find the maximum distance from the inclined plane attained by the particle. I think it's a very easy question, but it's very interesting. So let's draw some figure for this. Suppose this is our inclined plane, and it's having the angle 53 degree. Okay, and the particle is thrown. This is fixed, and particle is thrown from this inclined plane, this inclined surface, to some angle. It is 37 degree, right? 37 degree. So just move this, rotate this to have the feeling that it is being thrown from the horizontal, just to make the angle. Okay, if this is 53 and this is 37, so it should be perpendicular to this line. Let's draw this. Okay, so in this direction the particle is being thrown, right? Now let me move it to the original position. That means this should be 90 degree. This should be 90 degree. Like this. In this direction, the particle is being thrown. This is 37 degree. Now you can see the particle is actually thrown vertically upward from the ground. Vertically upward from the ground, but in 37 degree from the inclined plane. And we have to calculate the maximum distance from the inclined plane. इस inclined plane से कितना maximum distance दूर है ये आपका particle. So with reference to ground, this is the motion which is exactly vertically upward. That means particle will go like this, and it's not a projectile, it's come like this. So it's 1D. So we just calculate the direction things in y direction. Okay, so we know the acceleration first. Acceleration is minus 10 meter per second square. We know the final velocity, final velocity in y direction will be 0. Okay, we know the initial velocity in y direction, that is 10 meter per second. Right? We need to calculate the distance. Can we apply a third equation? Yes, we can apply. That means vy square uy square plus 2ay into sy. This is 0. This is 10 square plus minus plus 2 into minus 10 into h. H is this. Okay, this h will come out to be 5 meter. So this is 5 meter. Like somewhat here the particle traveled. This is 5 meter. So can you say that the distance between the inclined plane is 5 meter? No, we have to calculate this distance because it says the inclined plane, and plane is in this direction. So we have to calculate the perpendicular distance. Okay, and this is 5 meter. Angle is 37. This is hypotenuse. So this will be the sine of this. So sine 37 equals to this h we have to find h dash h dash upon 5. So h dash, as I said, ये आप इसको याद कर लो. Sine 37 क्या होता है? Sine 37 is 3 by 5. So 3 by 5 into 5 is 3 meter. So this is our answer. Okay. So students, till here we with this question we have completed the curvilinear motion. Okay, so just move quickly to our next topic, that is kinetics. So students, now we are going to continue our next topic, that is kinetics. So far in kinematics we have not considered the cause of the motion, but in kinetics we will consider the cause. What's the cause behind the motion of the an body? Okay, how the body is being having the motion. Okay, so let's understand with some example. Suppose here with we have given some force on this body, but body is not moving. Body is at rest. So what should be the condition here? That means the amount of force which is applied on this body is being consumed somewhere, or maybe we can say that maybe some external force is being applied on the body with that is in opposite direction. That is in opposite direction, and that should be in equal in amount. That's only the condition at which the object can be in rest. Okay, so these kind of things we have to see while considering the cause of motion, because the motion is not happening. So why motion is not happening? We will see that this. Okay, in this example, the inclined body is given and some object is being placed over it. It's having some mass. So what do you think? What do you think? Because as you can see, this body will move downward. Why will it move downward? Because it will having one force along this. That is a weight. That is the weight. And one component of this weight will be the cause of the motion of this body, which is pulling it downward, pulling it down to the inclined plane. So these cause we will talk about for this cause now. Okay, and this come under the kinetics. Okay, so let's move further. In kinetics, now we will completely study all the laws. We have seen the first law and third law in our first lecture. Now we will focus on, I'll just have the recap of first law. First law says the net force on the body is 0, which means if the body is at rest, it will remain at rest. If a body was moving with the uniform velocity, it will move with the same velocity. Okay, if a body moving with some velocity, it will remain move with that velocity, because there is no net acceleration of force. So no change in the state of the motion will happen. That was the first law. It's also called the inertial law. Okay, and third law we see that the one body have given some force to second body B. So the same force in same direction, and their direction must be collinear. So these forces are equal in magnitude and opposite in direction. Okay, every action has its equal and opposite direction. These two laws we have seen. Now the time to see the second law. So what second law says? Let's move to the next page. This. So second law of Newton's, second law of motion, or Newton's second law says that the change in the momentum of the body is directly proportional to the external force applied on it, and the direction of external force is along the change in momentum of the body. Right? Now, first thing we have to understand what is the momentum. I think you all know about the momentum. Momentum simply, it's denoted by the it's denoted by the P, small p, and it is simply the product of the mass and the velocity of the body. It's the product of a mass and the velocity of the body. It's simple momentum. It's also called the linear momentum. One more thing, whenever the word only momentum is being said or is being written, it's mean itself that it's a linear momentum. Okay, until and unless angular word is added before it, momentum. So if not is there, then it will be only the linear momentum. Okay, by default. Okay, so this is our linear momentum due by P. Okay, so whenever there is a change in momentum, rate of change, okay, there is a rate of change in momentum of the body. Okay, so now what is the mathematical interpretation of this? That means the rate of change in momentum of the body is directly proportional to the external force applied. That means if we remove the proportionality constant, that means it's equals to external force. And just elaborate this thing, I will put the value of P here. Mass is constant, it will not get differentiate. we got this external, and from here we got that the force is equals to mass into this term we have seen. This is the acceleration. This is the acceleration, net acceleration of the body. Net acceleration of the body. And from here we got the definition of we got the force. And from now I will not take this external. I will take this the net force equals to mass into the net acceleration. That means the net force applied on the body, it will give the net acceleration to the body. Okay, from now I will take this. So what is the use of this second law? Suppose, let's take fresh page. Suppose there is a body. Okay, 1 second. Take one body like this. Suppose this body having one force. Okay, this is F force, and it's, let's say, F1 force, and it's also having F2 force. But the body is moving in direction in this. Okay, in this direction is moving, and it's having a acceleration. And look, this acceleration is of the body. That means this acceleration should be the net acceleration, right? That means the summation of all these forces. That means F1 force minus F2 force. This is my net force, and this net force, which should equals to the mass into net acceleration. I will always follow this thing. First, I will write the net acceleration. Then I will equate it to mass into the net acceleration. I will always apply this thing. Second law of motion. Okay, I first write the net force, then I equate it with the mass into the net acceleration. Further, what I'll do, if the object is having a force, a system of force in two direction. Suppose system for the body having force like this, F1, F2. Okay, in this direction also F3, here also F4, and there is only acceleration of the body in this direction. There is no acceleration in the vertical direction from here. Okay, this is my net acceleration. So what I'll do with the equation, I'll write, because body is moving in this direction, I'll take this direction positive. So F1 in the direction of acceleration plus F2 in the direction of acceleration equals to, because direction of acceleration of body is this direction, so I will take mass into this acceleration. Okay, it will be clear more in the questions when we move. Okay, and the equation in this direction will be F3 minus F4, because these two are in opposite direction, equals to 0, because there is no acceleration in the vertical direction here. So I have put in this acceleration as 0. That's why the 0 is coming. So net force in the direction vertical to this is 0. There is only the force in this direction, because of this object is moving with this acceleration. Okay, so let's understand this more with some examples. So first we are taking the case for the Boolean string. Look, here there are two masses are mounted on the string, and this string is placed over the pulley, and this pulley is attached to some ceiling. Okay, let's take the mass here. This block A, this block B, and suppose this is having the mass MB, and this having the mass MA. Okay, MB and MA. These are the mass of this blocks. So as I told you earlier, in this, firstly what we'll do, we will do the FBD of all this. Okay, first we will draw the FBD of two blocks. in this, from here tension will be there, tension, and bottom there will be the masses, that means weight. Right. Suppose this is our A1, this is our A, block A, this block B, this is MAG, mass into aspirational gravity. This is the tension. Here the tension is T, because it's the same string. As told you, tension will be same, T. Okay. Now, if these two masses are having different mass are there, not equal, so what happened? This body will move downward because it's having the more weight, and this will move this body, this block B, upward. Okay, and their acceleration will be opposite but equal. So I consider the acceleration of block A is in the direction A, and for the block B is this. So this block A, it's having the net acceleration downward, and this block B having the net acceleration upward. So I'll first write the equation for this. That is because acceleration is downward, so I will take this as positive. So MA G minus T equals to M, because mass here is I will take the mass here of A, so MA into net acceleration, that is A. Similarly, write the equation for this block B. Acceleration is towards upward, so I will take T as positive now here. So T minus this is what? This is M B into G. So T minus MB into G equals to the net acceleration, that is mass of this body B into the acceleration A. This is the next equation. If you sum up this equation and calculate the what is acceleration, and you will find that acceleration is, you will get MA minus MB into G upon MA plus MB. By solving this, by just adding this, you will get this acceleration A. Okay, clear? And you can also find the T by putting the A in this. So this is the case inclined plane. In this, there is a fixed inclined plane having the inclination theta. Let's consider this is the mass M1, and this block having a mass. Here, this is the string attached with the pulley and to the block. Okay, as this is the same string, so tension here will be T. So here also tension will be C, because these are the same string. Firstly, what we do, we will just make the free body diagram. Let's assume this is the block M1 and this is the block M2. Let's take the block inclined as B. Okay, so here we can see the tension is this T, and it's having the weight downward, right? It's having the weight downward. This angle will be theta. So this component of the weight M1G will be M1 G sine theta, right? Same, I will draw the free body diagram of this. This is tension T, and the bottom, the weight will be there, M2G. Okay, so if I consider, because if I consider the M2 mass is greater than M1 mass, then motion will happen. This will move downward. This will move downward with some acceleration, let's suppose A, and this will move upward with the same acceleration A. Okay, so that means this block is moving upward, with the for the directions in this direction with the acceleration A, and this block 2 will move downward with acceleration A. So we will write the equation here in the direction of motion. So supporting force is T, I will take it positive, minus opposing force m1g into sine theta equals to this mass is m1 into that acceleration. Equation for this in the direction of motion, I will take this here m2g positive because it's because of this motion is happening, and minus t because it is opposing. Goes to mass here will come up this m2 into that acceleration. So from this we will get the. Okay. First thing what we will do, we will just make the free body diagram of the blocks. We will mark the forces, okay, and we will consider the acceleration, one direction of acceleration, and that will be my net acceleration, and I will write the net force equation for each and every object and find the equation, and with the help of these two equations, whatever is required in question we will calculate. Next, let's take the next case of lift. So this is a case of lift. This is very popular case of lift. Suppose this is a lift. In this lift, suppose one block is there which having the small m mass, and this lift is having the mass ml, and this is lift is attached with the string which having T tension in it. Okay, which having T tension in it. Clear? I will take, okay, first draw the free body diagram of these two. First I take the diagram of mass small m which is kept in the lift. So it will having the weight downward, that is m into g, and it will having the reaction, normal reaction upward. Excuse me for this normal reaction upward, right? If this is at rest, then this will be the free body diagram. But let's consider two cases. If the lift is moving upward, if this lift is moving upward with some acceleration, okay, with some acceleration A. So first case is lift is moving upward with A. Then what happened? I will take this case here now. This is my free body diagram of the object, and now what is happening? This is moving upward with an acceleration A. So who is carrying this block small m to upward? That is the normal reaction. So normal reaction is taking this block upward. So what should be the reaction? Sorry, not reaction, equation. N minus supporting force is m minus opposing force is the weight equals to m into A. M is because of m will come up for this block into this acceleration. And suppose if this block was moving downward, then case will be reversed, right or not? This here. Yeah. Now this acceleration is moving downward. This lift is moving downward. That means this block is also moving downward. So who is carrying this block downward? That is the weight. So if I write the equation, mg is supporting force. Now the normal reaction is the opposing force. So mg minus n equals to ma. Clear? So here the equation is reversed. Clear? Now if we draw the free body diagram of the lift, what will it do that? I have to take the tiny lift. Okay, assume this is a lift. So at this point, this normal which is acting upward, it will act downward for the lift. It will act downward for the lift. And this tension is here, which is moving upward. Same case for the lift. If it's moving upward, then equation will be moving upward will be T. So force which moving taking is upward T, so T minus N equals to net force. Net force equals to the mass into acceleration. Mass of lift is ml into acceleration A, by which it's moving upward. And if it's moving downward, then equation will be N minus T into ml into A, right? For this case, I hope ये चीज आपको क्लियर हुई होगी, how to write the equations. Clear? So that's it for today. We will take the questions in our next lecture. Thank you.